For our project, we decided to take apart an intake system from a 2004 Nissan Sentra with a 1.8 liter engine. We decided to take this apart because me and my partner both enjoy working on cars. So many engineering disciplines and functions went into building this entire system. There are over 20 parts that we've taken apart. Some of the parts could not be taken apart due to the fact that they are very sensitive pieces of equipment and sensors, or that they were pieces that were riveted in, and to take those apart they'd have to be drilled out, or the fact that without the proper tools it's very difficult to take them apart. So those parts are still in the car, and we'll take a video of that later. The main parts of this are the cone filter, the throttle body with the controlling computer, the piping that includes the sensors, and the main piping that helps the air get to where it needs to go. So this intake system actually was not stock on the 04 Nissan Sentra. The normal intake system was more bulky, lots of plastic, wasn't really efficient. It was more meant for the consumer, and it was a lot quieter. This intake system, it's called a short ram, and it's used to shove air into the car more rapidly, keeping the engine cooler, making it run more efficiently, giving you more horsepower, and if you're driving slowly, then it'll give you more gas mileage. On this type of car, the throttle body, which has a flap, is controlled by a motor, which allows air to go in and out, or not out, into the engine, so that it will mix with the gas where you get your air to fuel ratio. This flap has to be at a certain position at a certain time, because if it's not at that position, too much air will go in and the car will lean out, which means too much air, not enough gas, nothing works. Or it won't stay open long enough and you get too much gas, not enough air, which will flood the engine out, and then you're in trouble. On this car, the throttle is not controlled by cable like normal cars. It has a computer. This computer is dedicated just to the throttle body, but it's connected to the main computer that runs everything else in the car. You go from the throttle body, the next section is the main piping. This main piping is used to direct the air straight to the throttle body from the intake. After you get through the main piping, you go to the piping that's closer up to the filter. This piping also has wires that go to it. The wires that go in here go to a sensor. This sensor will allow the car to know what's going into the intake that's not oxygen. If enough stuff that's not normal oxygen goes into the car, it'll shut off immediately so that it doesn't run it into the engine. The very end of the car, the thing that most people actually see, is the filter. The normal filter is flat and goes in a box assembly. This filter is a cone shaped, which is more efficient for ramming the air in a circular pattern into the car. When the air spins, it causes the car to work more efficiently. The other parts involved in this, they don't seem like much, but they keep the filter secure onto the piping. Because if it's not on there tight, then you get stuff sucking in around it, and then your car could possibly die. It uses a lot of pipe clamps in there. The bigger pipe clamp is used to keep the filter onto the piping. The smaller clamps are used to clamp piping together, and then there's multiple small, really small pipe clamps that are used to keep the extra tubing attached to the main piping. The screws used in this are different than most screws. They don't have threading all the way up. They have a piece on the end that's not threaded, and they have a large section in the middle that's not threaded. There are many functions used to putting this whole project together. The design engineers started it from inception. They're the ones who took the system as a whole and designed a more fuel-efficient way of getting the air into the engine. The development engineers are the ones who took the idea, took the drawings, made working models, not full productions, and then they passed it on to the research engineers. The research engineers checked past products that had been made in this area. They tested it against the other failures that had happened when designing intakes. And then once they got a good idea of what they wanted to do with it, they sent it on to the test engineers. The test engineers designed tests that'll push the air through it to make sure it was going in the most efficient direction. And also to do tests on, like, tests to see how much wear it could take, how much of a beating it could take, how long it would take before it started decomposing, or before any parts needed to be replaced to try to get it to be in there the longest. The analysis engineers had it after that. They analyzed all the tests, made sure that it was good designs, that it was going to be fuel efficient, that it was going to be cheap. They analyzed all the data and signed off and gave it a thumbs up. It next went to the production engineers, which is one of the last functions of this project. The production engineers took all the designs, took all the data, made machines that would produce this at a good steady rate, and would produce it efficiently and cheaply. This system was actually designed in Japan by Nissan, but for the American market it is built in Mexico. All these parts are built in Mexico because it's cheaper to ship from Mexico than it is to ship from Japan. And that's just a quick look at everything that goes into the building and designing of an intake system for a Nissan Sentra.